Okay. So we have water, right? Or people say water. Or somebody says water. Right? What's the molecular formula of water?
H2O.
H2O. But the question is, why do we find water in various different states? How many states are there? 3 different states. On the surface of the earth, it is probably the only compound that is found in different states, in all 3 states. That is to say, you find water in liquid form where? In the sea, in the ocean, in the ponds, and where else? In your body, right?
Yes.
And also it can be found in solid state. Where? In the glaciers, in the mountains. And what about in the gaseous state? Here, right here, in the atmosphere, right? So, I have ice. I have water from the Himalayas, the Rasua, Himalayan coffee. I have, well, this is hot water, and I want to show you that there is vapor here, right? That's why I can feel some water here. You may not be able to see that. And what is this?
Coffee.
This is also water with some color, okay? Does it look like piss? Huh? But still it's water, right? Okay. The question is, why do we find it in different states? What is the difference between water in liquid state? What is the molecular formula of water in liquid state? H2O. Water in ice. What's the molecular formula? H2O, right? All of us know that. And what about in the vapor state? H2O. But what makes it liquid? What makes it solid? What makes it gas? The first thing that comes to our mind is about the kinetic energy or the temperature. When the temperature decreases, anything and everything turns into solid. That's our natural understanding, right? And if we heat a little bit more, it turns into liquid. And then if we heat further more, it turns into vapor. It becomes gas, right? Because of the change in the kinetic energy. When the molecules have more and more kinetic energy, they are more and more free to move. So that means when they are free to move, they create a lot of space between themselves. And when they create a lot of space, what happens? They occupy more and more space. When they occupy more and more space, what happens? They can flow from one place to another. So that's our understanding, right? Yes. Now, at normal, on the surface of the earth also, you can find water in solid state, right? In solid state, liquid state, right? So in order to understand why water exists on the surface of the earth, or what changes when water turns from liquid to solid, what change happens? Isn't that an interesting question? What really changes? What really changes when water actually changes from liquid to gas? Well, the temperature changes, it expands. But what happens between liquid and solid? What is the difference between this solid and this liquid? Can you tell me?
When ice melt, it expands its volume and it can move.
Is that true? Is that true? When ice melts, it expands. When ice melts, it expands. Who says this? Who says this? Who says this? For example, if you conduct an experiment, take a glass filled with water, liquid water, right? And then what do? And then put it in the refrigerator. Do you know what happens the next day?
Next day,
Sorry.
Do you think it's going to go down? The ice is going to be a little less, or ice is going to be a little more?
Little,
Less.
Yes.
No. It's going to be a little more. Okay. So, look at this. You take 1 liter water, that means you take a liter, a mug or a jug or a glass that is filled with water, contains 1 liter water, and then you also take another 1 liter vessel which contains 1 liter ice. The volume is same. The amount of water here, the amount of ice here, they are both same. But if you weigh them, what you will find is that the water will weigh about 0.99984 kgs or kg, and the ice will weigh not just 0.9182 kg. What does that tell us? That tells us that if you take same amount of 1 liter water and 1 liter ice, which one is going to weigh more?
Water.
Which one will have more mass?
1 liter water.
Water will have more mass. Isn't it?
Yes.
Isn't it?
Yes.
But the funny thing is, what's funny here?
But they have same volume.
Generally, what do we understand when more and more volume, when things expand, what happens? It becomes liquid. When things shrink, it becomes solid. That is our normal understanding. But in the case of water, it's a different thing, right? So in order to understand that, we need to understand something about the molecules of water. How do they stay with one another? There are many molecules here. Right?
Yes.
The molecule in water is H2O. The molecule in ice is also H2O. The only thing that is different is the way they live, the way they organize themselves with one another. What is the only difference? The only difference between ice and water is
Different.
the way they organize themselves. They organize themselves in different ways. Right? So, let's talk about this one here. H2O. Look at the water molecule here. Water molecule has a very special property in the sense that this oxygen, each molecule of water is made up of one oxygen, two hydrogen. One oxygen, two hydrogen. This fellow oxygen is a bit greedy. Alright? It wants to have more and more electrons. It tries to pull others' electrons. That's what I mean by greedy. Alright? Whereas hydrogen, when it comes in contact with oxygen, is a poor fellow. It tries to, okay, if you are going to grab my electrons, I'll give you my electrons. In the sense that hydrogen, the electron of the hydrogen will be nearer to oxygen. And oxygen will have more and more electrons around itself. It's not giving entirely, okay? The hydrogen does not give entirely, but what happens is that the electrons will be towards oxygen. So when electrons are more and more towards oxygen, electrons have negative charge, isn't it? And hydrogen will have less and less electrons towards itself, isn't it? So the charge of the proton will be greater than that of electron around the hydrogen. Whereas charge of electron will be more than the charge of protons near oxygen. So oxygen will have slightly negative charge around itself. The environment will be a little more greedy, little more negative. The environment around hydrogen will be a little more positive. So there is an area where the charge is positive, there is an area where the charge is
Negative.
Whenever you have positive and negative, what happens? There will be force of attraction. There will be force of attraction between opposite charges. So between water and water molecules, between water molecules there will be force of attraction. So what happens is, you see, oxygen is negative, oxygen is
Negative.
oxygen is hydrogen is
Positive.
positive. So they will try to be together. The oxygen of another molecule and the hydrogen of the other molecule will try to come closer. There will be force of attraction. That's called as the hydrogen bond. Similarly, again this one, you see, this hydrogen will try to form, try to be near this oxygen, so it's going to organize itself in that way. Similarly, this hydrogen. So you see what happened, what has happened here.
Yeah.
When they organize themselves, the hydrogen tries to be closer and closer to the oxygen of the other molecule. As a result, they will create some kind of room here, Baba. There is a small room here now. There is a small room. There is a little bit of space. And what happens is, in liquid state, the hydrogen bond is not very, it is strong. Hydrogen bond is not a very strong bond, okay? But the kinetic energy of the molecule, there is kinetic energy also, right? The molecule has a kinetic energy. So kinetic energy, what is the nature of kinetic energy?
It tries to.
It is always moving. It is always vibrating back and forth. But hydrogen bond is trying to make things stable, because it bonds with other molecules and tries to stabilize, right? So in the liquid state, what happens is that here, if you have a look, what happens is, this is the hydrogen bond in ice and this is the hydrogen bond in liquid state. So in this liquid state, what happens is, hydrogen bond is formed and hydrogen bond is again broken, because kinetic energy is more, right? The kinetic energy of the molecules is a bit more. So what happens? The hydrogen bond is formed and broken, formed and broken, formed and broken. There is space, but what happens? It is not solid, it is not stable. It is not stable. The hydrogen bonds are constantly broken and reformed. And that's the reason water is flowing. Water is flowing, right? And that's the state called as liquid state, when things can flow. Whereas here, if you look in the form, in this ice, the hydrogen bond is stable. It is stable. Therefore, water molecules don't move too much. And as a result, you have a solid state. What do you have? Solid state. So, what is the reason for, and in the case of vapor, gas, what happens?
They try to.
Actually, there is no hydrogen bond. That is to say, kinetic energy, wins over hydrogen bond. So molecules are not together. They are always floating independently here and there, here and there. So that's why you have gaseous state. Alright, so to summarize, what's the summary? The summary is that in the case of gaseous state, the hydrogen bond is, or the kinetic energy, the energy of vibration wins over hydrogen bond, right? And as a result, molecules are independent and free. In the case of ice, the hydrogen bonds are stable. So that's the reason there is no, breaking of hydrogen bond. So the molecules are stable. They are always together. Once the bond is formed, they will be always together, unless you provide external heat. And then in the case of liquid hydrogen, liquid water, what happens?
They form in break.
There is a constant formation and breaking of hydrogen bonds. So that's why it flows. That's why it does not have a particular definite shape. Because there is constant breaking and constant reforming.